October. I'm sorry for canceling this morning class. Basically, today was the due date for my research proposal, so I did not sleep at all last night. So I needed to take some sleep in the morning.
Sure.
And then, I still had a pretty busy day today. But anyway, let's teach. Let's start Econometrics. So today what I will teach is hypothesis testing. And then in my next class I will probably teach something like t distribution and f distribution. So basically, if you have studied statistics, you may learn about this kind of concept, t distribution and f distribution, and I'm pretty sure you are very likely to have no idea about what is t distribution and what is f distribution. So basically, after teaching hypothesis testing, I will teach what is the meaning of t distribution and f distribution, and also chi-square distribution. Basically, doing some kind of statistical analysis, like ignoring the basic concept of this distribution and only use the data analysis, that is also possible. And as I know, most of the people, they do in that way. But if you once learn about t distribution, f distribution, and chi-square distribution, the world of statistics is much more beautiful. And you can understand what's going on there. And when you learn something new about the data analysis, anyway, you can understand a little bit. Or you can simply skip, t distribution, okay, I think I know it. It's relatively simple. F distribution, yeah, I know nothing about it, but it is not that important. So let's skip this. And chi-square distribution, I also heard a lot about it, but I have no idea, not that important, skip it. I don't recommend those kind of things. Okay? So basically these kind of things are relatively three major. Actually, if you know something about chi-square distribution and f distribution, the other one is something called a normal distribution. Actually, in case of most statistics, we know nothing about the distribution. This kind of normal distribution is the only thing that we know pretty well. So this normal distribution is very frequently used. Most of the case, this normal distribution is used because we know something about what is the mean, what is the variance, what is the PDF or CDF of this normal distribution. We do know something about normal distribution. For the other distributions, if it is not based on the normal distribution, we have no idea. Then, what is chi-square distribution? This one is something similar to normal distribution. So basically, in theory, if I simply teach about it, you have something like epsilon I. This one. This one is distributed normal, mean zero, variance of sigma square. This kind of way. Or you can normalize it. I will teach it later, but if you know epsilon I divided by sigma, I told it. Then, what is it? Normal distribution, mean zero, variance of 1. I told the property of variance of x equals sigma square. Okay? Then what is variance of ax? That is a square sigma. Okay? I told you. A square. Okay? Then what is the variance of x divided by sigma? This one is 1 over sigma square times sigma square. Okay? I'm dividing this one by sigma, but because of property of variance, when you divide it by sigma, the variance, you need to multiply sigma square. Okay? That's what I emphasized. So you can see something similar here. This is mean, this is variance. Okay? When you divide this one by sigma, the mean is divided by sigma. But 0 divided by something, then still 0. When you divide this one by sigma, you need to divide this one by sigma square. Sigma square divided by sigma square, that is 1. This kind of variable is called as standard normal distribution. Okay? So we know something about normal distribution. When we do this kind of, we call it normalization. Random variable divided by its standard deviation, we normalize it, make the variance equals 1. Then this one is standard normal distribution. Because we know something about normal distribution, we also know something about standard normal distribution. Okay? Then up to here, most students, they memorize it, they understand it. And then what is the chi-square distribution? Chi-square distribution, we know something about standard normal distribution. What happens if we square it? When we square it, what happens? In many cases, in case of the variance, you squared it a lot of times. Okay? In case of the normal distribution, something you get positive value, sometimes you get negative value. When you sum them up, that becomes 0. Okay? Variance equals 1, but anyway, if you change that negative value into positive value, then you will get some measure. Okay? So, in this case, chi-square distribution, that is squared value of standard normal distribution. We know something about normal distribution. We know something about standard normal distribution. Okay? Then when we square it, this is some kind of variation of standard normal distribution. We still know something about it. Okay? So this one follows chi-square of degree of freedom of 1. It means that you added, you have only one random variable. Okay? In case of chi-square distribution, it has degree of freedom because sometimes, let me change the notation. Let's say, no, epsilon is the best way. The epsilon I divided by epsilon 1 divided by sigma 1, epsilon 2 divided by sigma 2. Epsilon 1 divided by sigma 1, this one follows normal, standard normal distribution. Epsilon 2, sigma 2, this one also follows standard normal distribution like this. Okay? Then, this one, you will get some value. This one, you will also get another value. Okay? But it is highly likely when you get something positive is possible, something positive, negative is also possible, something negative, something positive is possible, something negative and something negative is also possible. Okay? Then, in these cases, they will cancel out each other. Okay? Then, when we are interested in this kind of variable, standard normal variable number 1, standard normal variable number 2. But we are interested in some of this variable. Okay? Then, when this one happens, relatively okay. This one happens, relatively okay. Okay? The sign will not change. But when this one or this one happens, the value will be very similar to 0. And we don't like that kind of thing. Okay? Then how to solve this kind of thing? Square it, and sum it. Then this one, we know something about normal variable, normal distribution. We also know something about standard normal distribution. We know something about squared standard normal distribution, that is chi-square distribution, degree number 1. Degree of freedom number 1. This one follows, because we know something about this one, we also know something about this one. Basically, this one is positive, this one is also positive, because we squared it. Then this one follows chi-square distribution, degree of freedom 2. Okay? That's the meaning of the chi-square distribution. And this is the best intuition that I can give you. Okay? So we know something about this kind of chi-square distribution. Then there are 2 more distributions. I will teach these kind of things later, but 2 other things are, the first one is T distribution, the other is F distribution. Okay? Then let me teach. This one, T distribution is related to the ratio of standard normal distribution and chi-square distribution. Okay? So you can think about something like this. The first one, in general, we can say about something about beta. Generally, beta hat. Okay? This beta hat follows standard normal distribution. Something like this. Okay? In general case, what we use is something different. Usually, I said standard normal distribution, so let me change it. This beta hat follows normal distribution, but if you divide it by sigma, this one will follow standard normal distribution, this one. Okay? Beta hat follows something like mean beta, sigma square, something like this. Okay? But anyway, forget about it. This one is something like mean beta, that is more likely to be true, but this one is something like beta hat minus beta. This kind of thing is required, but let's forget about that part at this moment. Let's make it simple. Okay? This one. Okay? This one follows standard normal distribution. Okay? Then divided by something follows. Let me write it down later. This is too difficult. I need to teach something more, and this one. So let me write down in a different way. So the first one, this one, follows standard normal distribution. Normal distribution. And this second one follows chi-square distribution. Okay? So the first variable follows standard normal distribution. Second one follows the chi-square distribution. We know something about normal distribution. Okay? the only thing that we know is normal distribution. We also know something about chi-square distribution. Okay? This one is squared value of normal distribution. Okay? Then the ratio of this one follows t distribution. Okay? We know something about the numerator. It follows standard normal distribution. We also know something about the denominator. It follows chi-square distribution. Then the ratio of it follows t distribution. Okay? Then F distribution, this one is related to the ratio of two independent chi-square variables. Okay? So in case of F distribution, this one now follows chi-square distribution. This one also follows chi-square distribution. Then the ratio of it, we know something about chi-square distribution. We also know something about this kind of chi-square distribution. Then we know something about chi-square, this kind of distribution, that is F distribution. Okay? Then this one has some kind of degree of freedom. Okay? Something like K, usually this one is something like N. Then this one follows F distribution of degree of freedom of K and N, something like that. In case of chi-square distribution, degree of freedom is very important. 2 means that you summed up 2 standard normal distribution. 3 means that you summed up more. 3 standard normal distribution after squaring. Okay? So that is the basic idea of these 4 distributions. Okay? If you pay enough attention, this one was understandable, but trust me, most of the statistics teachers, they also do not know about this kind of thing. They just simply teach it. When students ask it, they do not answer, or students, they never ask about what's the meaning of t-distribution. I have no idea, but this one is for the final exam. Let's study it and memorize it, answer the question, get the grade, forget about it. But if you follow the basic reason, we know something about normal distribution, standard normal distribution, chi-square, square it. T-square, ratio of normal and chi-square. F, ratio of chi-square and chi-square after adjusting degrees of freedom. So we only know something about normal distribution. That's all we know about basic statistics. And all the other things are applied version of it. When you have something like this in your mind, all the complicated statistics is more understandable. It takes more time. You need to understand it, study it. Oh, what is it? Go back to the normal distribution, study it again, and what is it? Go back and study it again, go back. Eventually, you can understand this one. But this is the intuition. I'm pretty sure if somebody taught me this kind of intuition, my life would be much more easier. But nobody taught me about this. I cannot study this one by myself. Now I can teach you. Now, these 4 distributions, they are not entire mystery. They are something understandable. Okay? Then, what I need to teach is something like standard normal distribution and beta hat kind of thing. Okay? So, let's go back to that kind of basic things. Oh, I need this kind of thing, but I can write it down over time. So in OLS, go back to the algebra example. We have yi equals alpha plus beta xi plus epsilon I. This is our data generating process. Okay? We think epsilon I is the random follows mean zero variance of sigma square. Okay? Then we calculate beta hat. Okay? Then beta hat is summation I equal 1 to n xi minus x bar yi minus y bar divided by summation I equal 1 to n xi minus x bar square. This way. Okay? Then we also calculated variance of beta hat. Okay? This one is sigma square divided by summation I equal 1 to n xi minus x bar square. This way. Okay? Then what we need to know is this one. Sigma square. Okay? How did we calculate sigma square? We have no idea. So we estimated. This one is summation I equal 1 to n yi minus yi hat, the estimated value. Okay? This one becomes some kind of residual divided by n minus 2 because we lose 2 degrees of freedom. This way. Okay? This is the sigma hat square. Then, now, we know something about beta hat. We get some value of beta hat. In my 3-point example, this value is generally 1.5. Okay? You know something about beta hat. And here is some kind of data generating process. Okay? This is real beta hat. We want to know this one, or else will give me some kind of number of estimated value. In my 3-point example, that is 1.5. Okay? The question is, if this 1.5 is reliable, can I trust this value or not? That's the question. Okay? That kind of thing is related to hypothesis testing. Or this kind of data analysis is very frequently used. We can do hypothesis testing. And when the estimated value passes hypothesis testing, we think that value is reliable, or we can trust that value based on hypothesis testing. And that's the only way of checking if that estimated value is reliable or not. Okay? Then this kind of beta hat, if you remember, this one is unbiased. What's the meaning of unbiased? Expected value of beta hat, that is on general beta, the real value. Okay? OLS is unbiased. OLS itself is a random variable because it has some randomness, but on average, it will give you the real beta hat. The problem is that we are only getting one beta hat. Okay? So if you estimate it 100 times, on average, it will give you real beta hat or more. But problem is that we can do only one estimation. Okay? The value is 1.5. Okay? If you have some all the different estimated process, then this estimation will give you 1.5, another one 1.7, the other one 1.3, the other one 1.9. When you sum them up, you will eventually get 1.5. However, that kind of thing is impossible in the real life. You have some data set, you can do only one estimation. Then we need to use something different method. Okay? So in this case, basically beta hat is unbiased. Okay? Then it means that beta hat itself is a kind of random variable. It follows, let's assume the normal distribution. This kind of normality is now not anymore required, but because I taught all those kind of things based on normal distribution, let's use some strong assumption. Let's make it normal distribution. Then mean beta. Okay? On average, it will give you some kind of mean beta and variance of beta this way. Okay? This one should follow in that way, but we do not know this part. So we estimate it. How? Variance of beta. Okay? It is randomized. It has something like mean beta. It also has some kind of variance of beta, but we do not know what is variance of beta. So in statistics, we use something similar. What is something similar? Variance of beta. Yeah. Okay? So this one is more likely. Real beta follows beta, mean beta, variance of beta. Oh no, that's not possible. This real beta, it is not randomized. I'm sorry about that. So this is more likely to be correct, okay? This one is random variable. It has something randomness here. It follows something like this, okay? Then this one is, we can estimate it, okay? Variance of beta hat is this one. The problem is that we do not know this one. So we need something similar, that is sigma square hat, that is a variance of residual after adjusting degrees of freedom. Okay? So now we know this one, then we know this one as well. Okay? Then we have something similar to this one. Okay? Variance of beta hat, it has this kind of thing, but we estimate it, so we know something similar of this one. Okay? Anyway, that number is estimatable. Okay? Then in this way, we can think about some kind of hypothesis testing. Okay? So for this kind of hypothesis testing, we normalize it. What does it mean? When you subtract beta hat from beta, this way, okay, then it will follow normal distribution. This one has on average of beta, okay? When you subtract beta for everything, what is the mean? That is 0, okay? Variable x has normal variable mean 5, variance of 9, this way, okay? When I subtract 5 to this variable, then this way, okay? This variable simply moves to -5. Distribution is the same, but mean will decrease. Okay? This way. Okay? That is one step. Okay? Another one is when this one, then this one follows variance of beta hat. Then when you divide it by, okay? When you divide it by variance of beta hat, this way, okay? Oh, square root, I'm sorry. This one, okay? when you divide it by variance of beta hat square, sometimes this is not entirely correct. In that case, I follow most intuitive way. But anyway, when this one happens, what happens? Here, what you get is variance of beta hat divided by variance of beta hat square root. You need to square this way. Okay? In this case, if you divide it by 3, what happens? You need to divide this number by 3 square. Okay? Then this number you need to divide it by 9. Okay? Variance of ax equals a square variance of x. This way. Okay? This one is very important. Okay? Then when you divide by variance of x, divide by a square variance of x. This way. When you divide by 3, you need to divide by 9. Okay? What we want is make this number equals to 1. Okay? Beta hat follows this kind of variance. We want to remove this mean, so subtract beta. This one will become 0. Okay? We also want to remove this part. Okay? Then how do we do it? This one is variance, square root. This is called as standard deviation. Okay? Square root value of variance, we call it standard deviation. Okay? Sigma square is variance. Square root value of sigma square, that is sigma. This one is called as standard deviation. Okay? Question? So, this is standard deviation of beta, or square root value of variance of beta. I prefer this kind of thing better. Okay? Then anyway, through this process, we can get some statistics. Okay? Then, this kind of, through this normalization, we can make this value into standard normal distribution. Okay? Variance of beta hat, it has mean beta, and variance of beta hat, but we are able to estimate this one, and then later, what we really use is not this kind of thing, but t distribution. In case of t distribution, indeed this kind of sigma squares are cancelled out. But let's talk about that later. This time, just think about normalization. Okay? So we can normalize it. Then this value will follow this one. Okay? Then what is the property? Can I name this one? Then what is property of normal distribution? The property of normal distribution, it has this kind of bell curve. Okay? And it has mean mu. Mean mu. Okay? It has some kind of mean, and it has variance. Okay? So we like standard normal distribution because when we know the mean and variance, we know the shape of this bell curve. Okay? So in case of the line, when you know slope and the intercept, you know what is the line. Okay? In case of standard normal distribution, it is slightly more complicated. But anyway, when you know mean and variance, then you know this shape. That's why we like normal distribution. Okay? And this is the only thing that we know. In case of standard normal distribution, it has mean 0 and variance of 1 square. Okay? This kind of variance is the measure of data dispersion. How far you are from the mean. Okay? So when you are closer to the mean, you are more likely to have this kind of variable. When you are further from the mean, you are less likely to get that outcome. Okay? That's the meaning of standard normal distribution. Then we are using the property of this kind of standard normal distribution. In case of standard normal distribution, what we have is probability density function. We generally call it as PDF. Okay? You will see this kind of term so many times in statistics. PDF. Probability density function. Okay? Then to explain this kind of probability density function, I need to teach two things. One is discrete variable. The other is continuous variable. Okay? So in general way, this kind of discrete variable is more intuitive. Okay? So in this kind of discrete variable, you have limited number of outcomes. For example, you can think about one discrete random variable, coin. Okay? This is random variable. What kind of outcomes are possible? Head or tail. Okay? Coin is a random variable. You may get head, you may get tail. Okay? So then you can think about probability of outcome. Probability of getting head is half. Probability of getting tail is half. Okay? So in terms of graph, I may write it down this way. This is head, this is tail. Probability, you have half of it here, another half here. Okay? In statistics, we call this one as some kind of probability mass. Okay? It has some kind of mass, okay? Something tangible. Okay? You can estimate it. Okay? So you have probability mass here, half and half. This is what you have in your mind in terms of statistics. Okay? Coin will give you some. Coin is a random variable. It has two outcomes, head or tail. Then probability of getting head is half, probability of getting tail is another half. Okay? But in this kind of normal distribution, this kind of way is not correct. Forget about it. Okay? It's a totally different world. In case of this kind of normal distribution, what we have is this kind of continuous random variable. Okay? Then in this kind of continuous random variable, there are unlimited number of outcomes. This is different. Okay? Then we can think about one random variable. In that case, let's call it something like x. But it has unlimited number of outcomes. In case of discrete variable, it only has two outcomes, limited number of outcomes, head or tail. Okay? Then it has probability mass, half in the head, another half in the tail. However, in case of unlimited number of outcomes, variable x can be 0, 1, 2, 3, 4, 5, 200, 200, whatever. It is also possible negative 0, 1, these values. Also negative 0.5, negative 2.5, negative 3.7123, negative 3.333334. All these values are possible. Okay? Then probability mass, something like this, do not exist. Okay? Because there are too many cases. There are too many number of outcomes. Okay? Then that is one outcome divided by unlimited number of outcomes. This probability is basically 0, or it converges to 0. Okay? So in case of continuous random variable, you cannot think about what is the probability of x equals 0, something like this. This is 0. Or you cannot measure it. You cannot calculate this probability measure. Okay? That's the difference. So in this kind of continuous random variable, what we can calculate is probability of x equals 0, that is not possible. Or we can calculate it as, basically this is, in mathematics, we call it unmeasurable. Okay? The meaning of it is that, think about this kind of line. Okay? This kind of line, basically it does not, we cannot measure the area of the line. To measure the area of the line, you need height and the width. Okay? To measure the area, you need what is the height, what is the width. When you multiply, you can get the area. But in case of line, in theory, it do not have the width. Okay? When it has the width, it became a plane. Okay? This one is plane, not a line. Line is here. Okay? So in case of measure theory, this is the area of the plane. Okay? When you remove this line, area is still the same. Okay? This one and this one is smaller. You removed one line. Okay? But in terms of the area, because the area is line is 0 or unmeasurable, they has the same area. Even if you remove one line from this, even if you remove 10 lines, 100 lines from this one, in terms of measure theory, area is the same. Okay? That is something like you cannot calculate the probability mass of continuous random variable. Okay? In case of continuous random variable, it does not have probability mass, only probability density exists. Okay? So you know there's some kind of height like this. Okay? When this height is high, you are more likely to get this value. But what is the probability of getting this number? You cannot measure it. It is the area of the line. Okay? So to calculate the probability of this kind of random variable, the normal distribution, you need the width. Height is given by the normal distribution. Okay? Then what you need is the width to calculate the probability of this random variable. Okay? Then when you have probability density function or when you have continuous random variable, what we can calculate is probability that this variable x is less than 0. This is possible. Okay? When you have a random variable, okay? This is the random variable, okay? Mean is 0. Then this is symmetric. So probability of getting positive number is half. Probability of getting negative number is half. Okay? What is the probability of getting number 0? That is unmeasurable. Okay? The probability of getting 0 exists, but because it does not have width at all, only it has the highest density, but we can ignore bar. Okay? Then probability of getting that this continuous random variable is less than 0, that is half. Probability density function, this x is larger than 0, that is also half. Okay? Also, probability of x is less than or equal to 0, this is still half. Because this line is not measurable. By adding this one line, the area is still the same. Okay? So in this case, we can also calculate something like this, the probability that x is between 0 and 2. Probability that x is between 0 and 2, okay? That is the area under this curve. Okay? Now you have this kind of height, this kind of width, and when you do calculus, okay, you can also calculate the area of the line. That kind of thing is called integration. Or you may heard about this kind of term, integral. Okay? When you measure this kind of area, when you know the derivative of it, you can measure the first value and the last value. Okay? So basically, when you know, we know this function. This is normal distribution. When we know mean and variance, we know the functional form of this curve. And when you use the integration calculus, you can calculate area under this line between these two values. Okay? And don't worry about it. Statisticians, they already calculate this number. You have seen some table like this, 1, 2, 3, 4, this way, 0, 1, 2, something like this, and then you find some line and calculate the value. Okay? That is what statisticians calculated about what is the area between this one and this one, something like that. Okay? So in this case, what is the most frequently used is that what is the probability that x is less than 2? Okay? Here is number 2. What is the probability that x is less than 2? This is 0.025. Okay? So when this is a kind of standard normal distribution, we subtract the mean and we divide it by its standard deviation. So mean 0, variance of 1. Okay? Then basically this means that variance is 1, standard distribution is also 1. The chance that you are likely to get the value bigger than 2 standard deviation is only 2.5%. Okay? Standard deviation is measure of data dispersion. Okay? So 2 standard deviation means that in terms of measure of data dispersion, you are twice bigger than average data dispersion. And in statistics, based on this normal distribution, the chance that, different way. Yeah, this one is, 0.975. This way, the other way. Yeah, that's my mistake. Okay?
The remainder of it.
Yeah. So the probability that this x is larger than 2 is 0.025 this way.
Right.
Yeah. Okay? The probability that you are getting the value number less than 2 is pretty high. Probability that you are getting this number larger than 2 is only 2.5%. Okay? That is one way. The other one is the probability that x is less than negative 2. Okay? Getting the value this is negative 2. The probability that you are getting the value less than negative 2. This is also 0.025. Okay? Then by using these two chances, we do define 5% and sum them up. 5% significance level. Okay? This one is most frequently used kind of, how can I say, distribution. This number is in real is something like 1.96, something like that. But in general, we use 2 for simplicity. Okay? So using 2 is totally fine. So in most cases, when I do this kind of data analysis, I see what is the value. Is it larger than 2 or less than 2? I like it. If it is that smaller than, it is between negative 2 and 2, that means that people will not trust your data analysis. Okay? So this is 5% significance level in this way. Okay? So in case of continuous random variable, what you can calculate is something like this. What's the probability? This random variable that follows normal distribution, that outcome is larger than 2. That chance is very small. Okay? What is the probability that this number is less than -2? That chance is also very small. You can still have this kind of thing with this kind of 2.5% level, but in statistics, at the 5% level of significance, you can reject those kind of possibilities. Okay? That's why statistics is so popular. In case of mathematics, when there's 5% of probability of getting something, you cannot ignore that.
Mhm.
In case of statistics, when there's something, some probability of 5%, okay, forget about it. Okay? So that is the difference, and that's the meaning of probability density function. Okay? Then, in terms of hypothesis testing, we have two hypotheses. One is null hypothesis. Another is alternative hypothesis. Okay? Basically, null hypothesis means that there's nothing. It is just random. You were just lucky to get that value. Alternative hypothesis is that you can reject the null hypothesis. Basically, null hypothesis in OLS means that there is no relationship between x and y. X and y, they have no relationship at all, but because of some randomness, because you are lucky, you got some relationship. But statistically, that kind of thing may happen with high probability. Alternative hypothesis basically means that null hypothesis is not true. Null hypothesis means that x and y, they have no relationship. Alternative hypothesis means that you can reject the null hypothesis. Means that there is some significant relationship between x and y. Okay? So in OLS, null hypothesis is beta equals 0. Okay? Data generating process is yi equals alpha plus beta xi plus epsilon I. This beta determines the relationship between x and y. If this beta equals 0, it means that there is no relationship between x and y. Okay? But if alternative hypothesis means that null hypothesis is not true. We do have some relationship between alpha and beta, x and y. Okay? Then how do we do this kind of hypothesis testing? We assume that beta hat follows normal, mean beta, and variance of beta hat. This way. This is the simplest institution. In statistics, it is more complicated than that, but at your level, this is the most intuitive. Okay? So beta hat, this one has randomness because of this error term. Okay? But beta hat is unbiased. It has, on average, mean beta. Okay? but it also has some kind of variance of beta hat. Variance of beta hat, what is that? Sigma square summation I equal 1 to n xi minus x bar square, this one. This is variance of beta hat, okay? But we do not know sigma square, so we estimate sigma hat square, that is summation I equal 1 to n yi minus yi hat, this one, okay? What we need is this one, but we do not have this one. This one is something similar, okay? Then we have some kind of estimated value of this one, okay? Then now we can do some kind of hypothesis testing, okay? Null hypothesis says that beta, real beta, is 0. That means that there is no relationship between x and y. Alternative hypothesis says that no, null hypothesis is not true. Okay, there's some relationship between x and y. Beta is non-zero. Okay, then what we need to do is reject the null hypothesis. How? Under the null hypothesis, we think beta equals 0 is true. Okay? Under the null hypothesis, we think beta hat equals 0 is true. Okay? Then, basically, we are normalizing this one. Okay? This is normal distribution, but when we normalize it, this one becomes standard normal distribution. Okay? How do we normalize it? Subtract the mean and divide it by square root value of variance of beta hat. Okay? Actually, we need to use something different, but this is the only estimated value, so we are using this one as a proxy of it. Okay? Then, under the normal distribution, it follows this kind of mean, and under the null hypothesis, it also has some kind of variance of it. Okay? Later, you will see that sigma square is needed, but they are cancelled out, and because of those kind of things, there are some kind of different thing also happens, but at this moment, forget about that. Okay? This is most intuitive. And then, let's revise your understanding later. Okay? When you standardize it, this one follows normal distribution, mean 0, variance of this way. Okay? You subtract the mean, this one disappears. Okay? You divide by this one, then when you divide something, variance, you need to square it. The square root disappears. Divide this one by variance of beta hat, you will get number 1 here. This one is standard normal distribution. Okay? Question? Then, under the null hypothesis, oh, I need this one, but anyway. Under the null hypothesis, beta equals 0. Okay? Then, under the null hypothesis, your beta is here. This is your beta. Okay? Okay? And this beta equals 0. Okay? And then it also has some kind of variance. Okay? It has some kind of variance of this one. This way. Okay? It has some kind of randomness, but we do not estimate it exactly, so we are using some kind of proxy of it. Okay? That's the only way that we can estimate this one. Okay? Then, this is the variance. Then, when you standardize it, okay? When you standardize it in this way, okay? Then, beta hat minus beta, this one, divided by square root value of variance of beta hat. This one follows mean 0, variance of 1. Okay? So under the null hypothesis, when you standardize it, here is 0, and this is the variance of 1 when you standardize it. Okay? Then this kind of standardized value, probability that this value this is standardized random variable. When this value is larger than 2, that is 0.025. Not very likely to happen. Okay? Also at the same time, probability that beta hat minus beta
Small.
negative 2 is very small. Okay? Then, when you get this number, something like beta hat minus beta square root variance of beta hat is, let's say, this number is 3.5. Okay? This value is under the standard normal distribution. Getting the number 3.5, you can still get it, but it is not very likely to happen. Okay? Under the null hypothesis, mean equals 0. Okay? Under the null hypothesis, mean equals 0, then when the mean is 0, the number 3.5 is unlikely to happen. Okay? The probability that this kind of 3.5 is came out because of pure law is less than 2.5%. Okay? Then we reject. The null. Because under the null hypothesis, number 3.5 is not very likely to happen. Okay? Then we think beta hat, its mean is not here, but here. Okay? Under the alternative hypothesis, okay? Under the alternative hypothesis, beta is not true. Okay? Then under the alternative hypothesis, beta hat 0, this is not true. Then where is our beta hat? Where is our mean? It is more likely to be here. Then under this distribution, number 3.5 is more likely to happen. Okay? Under the null, we think distribution is this one. then this value is not very likely to happen. Then reject the null. Then under the alternative hypothesis, we think mean is not 0, but 3.5. When the mean is 3.5, and we assume that distribution is this way, number 3.5 or something similar is more likely to happen. Okay? So in this kind of hypothesis testing, we are rejecting this distribution, and accepting this distribution. Okay? That is hypothesis testing. Okay? So this is not entirely correct, but this is the simplest intuition. Okay? Before you are running t distribution and f distribution and chi-square distribution, everything completely. There are some ways to teach it, but I prefer this way. This is most intuitive. Indeed, this is not statistically completely correct, but this kind of understanding is enough. Or this one is even better than no understanding. Okay? So I prefer to teach in this way for the first time. And then I will teach t distribution and f distribution and chi-square distribution, those kind of things, and then I will be back to here and revise some of my mistakes. Okay? That's why I try to explain it in the beginning and forget about it. This is too complicated. Then this way. Okay? Question? Okay. Then I think I can stop my class number 1 at this moment.